Okay, so just a reminder, we have a test on Tuesday. Today we are doing quick notes on Euclidean versus spherical geometry. We will begin to be able to do the review, and then we will be reviewing on Monday because we have a test on Tuesday. So, today's notes. Begin, if I can click, there we go, like this. Okay, so everyone has the half sheet of paper for the notes. Okay. I will let you know when to write. Right now you don't have to write anything down. But we're going to explore for a minute or two the different types of geometry. So here we go. Euclidean geometry. This is probably a new word for you. Okay. Euclidean geometry is basically high school level geometry. It's the study of geometry based on definitions, undefined terms, and assumptions of the mathematician Euclid. Euclid lived 330 BC, long time ago, okay, BC, before Christ, right? It's based on all the basic definitions we learned in week 1, point, line, plane, etc. So again, geometry is old, right? So this is a picture of the guy looking happy. Euclidean geometry. Euclid of Alexandria was a Greek mathematician often referred to as the father of geometry. It's his fault we take geometry, but it's a good thing because it explains a lot of our world. In Euclidean geometry, Euclid's approach to geometry consisted of proving all theorems from a number of postulates. Now, postulates are like theorems, they're basic assumptions. He had a few basic set of assumptions that he derived or proved all of the geometry that we're learning this year. Okay, and it's basically a study of flat space. So like piece of paper, flat desk, whatever. You can easily illustrate the geometry that we're doing this year on a piece of paper because it's flat. Okay. The concepts that in Euclid's geometry remained unchallenged. So basically it was the standard up until the 19th century. And at that time, other forms of geometry started to emerge. So there's Euclidean geometry, what we're going to learn this year. And of course, then there's the non-Euclidean geometry. Okay? It was no longer assumed that Euclid's geometry could be used to describe all physical space. Okay? So, this is where we're going to write on the left-hand side of our notes. These are the basic things that you either know or you're going to learn this year about Euclidean geometry. So the first blank, the shortest distance between 2 points is a straight line, right? Perpendicular lines intersect one time, okay? Parallel lines do not intersect. It's kind of the definition of it. And in a triangle, if you add up all 3 angles, it equals 180, okay? So those are some basic flat Euclidean geometry facts. Everyone's got that? Almost. Okay, we're moving on. Non-Euclidean geometry. So, non-Euclidean geometry is any form of geometry that contains a postulate which is equivalent to the negation of the Euclidean parallel postulate. Now, that's a mouthful, and I know we haven't talked about the parallel postulate, and we're not spending a lot of time on this, so let me just make it as simple as I can. If you take the assumptions that make up our flat geometry, if you take away one of those assumptions, you can create a whole new geometry. Okay? So there are different types of non-Euclidean geometries. One of them is, as you can see in my hand, spherical, like a ball, basketball. There's also taxicab geometry, and there's also hyperbolic geometry. And those things you learn potentially in college if you take an upper level geometry course, okay? So they're actually pretty interesting. We just don't have time because we got to learn Euclidean this year. We're just spending a few minutes on spherical, and here is the info on spherical. We're not writing yet, but spherical is the study of curved surfaces, obviously, like a sphere. Okay, you got a ball here, the Riemann surface space geometry. Notice how there's like a triangle. If you put 3 points on a sphere, like I did here, no pun, no rhyme intended, but you can see I put between these 3 points, I got these angles, and it makes a curvy looking triangle on the surface of a sphere. So consider what would happen if instead of working on a flat surface like Euclid did, if you worked on a curved surface, okay, such as a sphere. Why would that be important for us? Geography, because Earth is a spheroid, yes. So, hopefully we're all in agreement. So, Earth is a spheroid, meaning it's not a perfect sphere because it's got mountains and valleys and all that stuff, right? So it's not a perfect one, but a globe, a sphere, right? So a study of spherical geometry has direct connection to our daily existence since we live on a curved surface called planet Earth. Believe it. So, there's some video examples we could watch that we are going to bypass here. And here's a question that's not supposed to be question 2. It's supposed to be question 1. It is what it is. What is considered to be a straight line in spherical geometry? Okay. So, with my basketball, okay, there are lines on here, quote unquote. So, not the weird one. This one right here, okay? So this is a line on a sphere. What do you call it? What do you call that? It's like an equator, but what do you call it? This thing that goes around in a circle. Thank you. So it's a circle, right? The geometric shape is a circle, right? Sorry, I should have said geometric shape. So if you go in a straight fashion on the surface of a sphere, you will get a circle, right? And this specific circle is called a great circle. You don't have to write it down yet, but this is called a great circle if it's around the largest part of the sphere. Okay? So just like the equator is a great circle. Okay? Now, there are circles that are not great circles. So for example, like near the top, something like this, if you can see that, okay? That's not around the largest part of the sphere, okay? Great circles have to be along the widest part. So, if I had 2 great circles that were perpendicular, and I have an example right here on my ball, okay? That's a right angle. That's perpendicular, okay? Do these lines intersect, okay? Perpendicular lines do, but also parallel lines, which is weird, okay? So if you know your geography, you know that longitudinal lines are vertical. Am I right? Yeah, longitude is vertical, right? Or seemingly, so to speak. I know it's all positional and relative, but nonetheless, vertical. So check it out. Longitudinal lines don't cross until they touch at the pole, right? So those are all great circles, longitudinal lines, except they do touch twice. So they're parallel until they get to the pole, okay? So again, every line in spherical geometry that's a great circle is going to intersect, even parallel ones. And what about the angles? So if you look at my example right here in my hand, I drew my triangle. Typically, a triangle only adds up to 180, but let's look at this. I got a 90-degree angle, a 90-degree angle, and a 90-degree angle. That is more than 180, right? That's 270. So it's possible in this picture, which if you're watching the video, you will not be able to see it, but it is what it is. 50, 90, and 90, that's more than 180, okay? So there's a picture, yay. All right, here's what we're going to write on the right. That's right. Spherical geometry. So this time, the shortest distance is not a line, it's a great circle. Perpendicular lines intersect twice. So that's what I was showing you on the basketball, okay? These are perpendicular, they touch here and on the other side, okay? Parallel lines do intersect. The example is like lines of longitude touching at the north and south pole. And on the last one, notice A plus B plus C is greater than 180, okay? So as you finish writing that, I'm going to pass out a should-be short assignment. this could take you a few minutes. You can turn it in. So, check it out. So put your finger right there, and then those same two circles come over here, and then they right there. Those are the same circles on each side of the exactly like poles on the basketball. All right, so. Cool. You can put that in the turning bin. Now, class. Real quick. Everybody's attention. Oh, sorry. When you finish, does everyone see there's a red little sign over there that says, grab a review? When you're done, I want you to grab a review. And if you already grabbed a review, you grabbed the wrong review, so you can come back and give it back to me. Because this is the right review. Right here. For y'all. Okay, so what you're going to do is, on 1 through 6, you're going to tell me, is it Euclidean or spherical? One or the other, okay? And then people are getting stuck on 7, 8, and 9. So if you hear me, you will get 7, 8, and 9 correctly. So on 7, 8, and 9, they give you 3 angles. If you add up those 3 angles and they equal 180, what type of geometry is that? Euclidean equals 180. What if the angles add up to more than 180? Spherical. That's what we learned on the notes that you have in front of you, right? But what if it's less than 180? I haven't talked about that. That is actually not a geometry I know of, so that is neither. Okay? Less is neither. Equal Euclid, EE, and then greater than is spherical. Okay? On the last two, make sure if it's false, you rewrite it. You could do this in a couple minutes, be done, turn it in, and start the review, please.